Hello everyone, welcome back to the channel uLearn Education Online.
In the previous video, we have seen one parameter of a DC characteristics, that is input bias current. Okay, so here why we are considering these characteristics is, even if the AC signal is 0, the output voltage should be 0. But because of the internal parameters of operational amplifier, the output voltage is not equal to 0. So in order to maintain the output voltage to 0, we are using some compensation techniques to the op-amp circuits. So we have seen the first parameter, that is input bias current. Now we are going to see the second parameter, that is input offset voltage. Okay, now we are going to see what is the definition of input offset voltage. So the input offset voltage is nothing but the differential voltage that is applied between the two terminals of op amp in order to make the output voltage is 0. Means the voltage that is applied in between the two input terminals of op amp is nothing but the input offset voltage. Now why we have to consider this input offset voltage? Even though in the input bias current we are providing some compensation resistor, that is R compensation, even though with the provide of that R compensation resistor there exists some small amount of an output voltage. So in order to maintain that output voltage to 0, some small amount of input voltage that must be applied at the either terminal of op amp. We are calling that voltage as the input offset voltage. So it is indicated with V suffix IOS. Here this IOS is input offset voltage. Now let us examine what is the effect of input voltage offset voltage that is present for inverting and non-inverting op amp. Okay, now let us consider that inverting circuit and non-inverting op amp circuit in closed loop configuration. Okay, so this one is the inverting amplifier and this one is a non-inverting amplifier. Now for example, let us consider the non-inverting amplifier. Okay, so for this non-inverting amplifier, in order to know the effect, we have to maintain this AC signal as 0, that is Vi is 0. If you obtain the Vi as 0, then we can redraw the circuit as, so this here it is connected to ground. Now what we are saying, this input offset voltage is nothing but the voltage that is present at the input terminals of op amp. So here the voltage at non-inverting terminal is 0, whereas the voltage at inverting terminal we are considering it as some V2, and this V2 is nothing but the voltage drop across the resistor R1. So here this VIOS is nothing but magnitude of V2. Now we have to obtain what is the output voltage V0. Okay, so here this V2 is nothing but the VIOS and V2 is nothing but the voltage drop across the resistor R1. Simply we can apply the voltage division rule or the potential division rule. Okay, so from that we can write V2 is nothing but the voltage drop across the resistor R1. So V2 is equal to total voltage. So now what is the total voltage? It is V0. Okay, so V0 into branch impedance, that is R1 by total impedance, that is R1 plus RF. Okay, so finally the V0 expression we are obtaining as V2 into 1 plus RF by R1. Now what is the value of V2? So here V2 is nothing but the VIOS. We can write VIOS is nothing but the difference of two input terminals. So higher potential minus lower potential. So it is 0 minus V2, which is equal to V2. So finally the V0 expression is nothing but VIOS into 1 plus RF by R1. So with the minimal amount of this input offset voltage, we can obtain the V0 value as 0. So this is one parameter that is affecting the output voltage V0 0 even if the input voltage is absent. Okay, thank you.